think maybe we need to talk through this one, huh? No? Don't want to talk through this or let you keep working? You have to approximate, yeah. Yeah, let's go through this one, and then I'll give you another one that's a little bit easier to work with, okay? Like the one before this one. Okay, so everyone's okay? This is a quadratic function, right? It's an expanded form. Its parabola opens up. The vertex, we're going to use the shortcut, so it's negative b over 2a. Is that okay with everyone for that?
Yes.
And then you can reduce the fraction, you get 4/3, which is 1.33333 repeating forever, right? So you can't really stop it, but we have to at some point stop it. If you plug 4/3 into this, then here's how you do it, leaving everything as a fraction. Right? You square it. What's 4/3 squared? You square top and bottom. Times 3 is the same as 3 over 1. Here, 8 is 8 over 1 times 4/3 plus 2. Right? This is if you don't want to use your calculator, which I would. I mean, we're all people who are going to do more math, right? You're going to take calculus, and I want to be a computer science, and I want to be an engineer. You've got to be comfortable working with fractions. You can't always see a fraction and go, and just start wilting away. Okay? At some point, you have to be able to work with them. This is the proper way to work with that fraction being plugged into that function. This is all arithmetic, right? And then you try, I did this. I did 3 goes into 3 once, 3 goes into 9 3 times, and you got 16/3 over here. Couldn't do anything except put straight across 32 over 3. Then 2, I turned it into 6 over 3 because I knew I was going to need a common denominator, put them together. And then it's just a matter of 16 minus 32 plus 6 is this. Yeah? So negative 3.33. Anybody do it with their calculator? No? Tried? Were you able to get this?
Yeah. Oh, I didn't get that.
You did get that? Yeah? Okay. So if you're going to go to your calculator, make sure you're accurate with that you're actually getting the correct answer.
I just went through the trouble of turning it on and stuck multiplying.
Pardon?
I got it.
You got hung up in here? Yeah.
Fractions.
I just completed the square.
You did completing the square?
Yeah.
Did it work?
Yeah.
Yeah? So that wasn't that painful? Okay, good. Okay, we've got our vertex. Quick sketch. Quick sketch. So I'm on part D. Quick sketch. Our vertex is 1.33 down 3. All that matters to me is I'm down here, right? I don't really care where. I'm just like over and down. And it opens which way? Up. Since it opens up, you're going to hit the x-axis twice. 2 X intercepts, right? That means you have to go find them. How do you find the X intercepts of a function? I'm saying in general, not just like a parabola. If you have any function, how do you find its x-intercepts? Set it to 0, right? That's how you find the x-intercepts of a function. So I want to take this function, I want to set it to 0. So take 3x squared minus 8x plus 2 and set it equal to 0. That's how I'm going to find my 2 x-intercepts. Right? That's how I'm going to find these. And that, you have all sorts of choices on how you want to solve that. You could try and factor. Maybe it factors. If it doesn't factor, what can you guarantee go to? Quadratic formula. I'm going to go for the quadratic formula. So my answers, x, are equal to negative b plus or minus square root b squared minus 4ac over 2a. All right. Which is? Yeah, we're going to need our calculator for that, I think. All right, so what's negative b for us? We've got 8 plus or minus. What was your name again? Abby. I always feel like I'm like you're the only student I feel like I'm in your vision the whole time, like I'm blocking you.
No, just.
I mean, you can always move over if you want. It looks like you have that table to yourself. 8 plus or minus
The square root of 64.
square root of 64 minus 4 times 3 times 2 the entire quantity divided by 6, 2 times 3. In here, we get 12, then 2, 24. We're going to take 24 away from 64. So root 40 all over 6. And you could start figuring out what this is, right? Like you could break the 40 down. But at the end of the day, these are 2 points on our x-axis, aren't they? And I don't care how pretty you make this look as far as pulling things out. I don't think anyone here has any idea where these are, right? Until you get it as a decimal. Then you'll have a better idea. So at this point right here, let's just take square root of 40 on the calculator. So go ahead and do that. 6.32, what would it say 6.32? So at this point I'm going to say, instead of equals, 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 I'm going to say approximately 8 plus or minus 6.32 all over 6. And that gives us 2 answers, right?
Yes.
We have 2 answers. It's the plus case and the minus case. So let's look at the plus case. 8 plus 6.32 over 6. So 14.32 over 6, which is 2.38? Okay, and then on this one, 8 minus 6.32 over 6, which is, go ahead and just give me the whole thing, figure it all out. 0.38?
I got 0.28.
0.28? Make sure you, if you're going to do it, you have to do the top first. Figure out what that is. Then divide by 6.
I got 0.28.
Okay, yeah, no, I'm not saying you're wrong. You got it? Remember that this big division bar means all that has to happen first. If on your calculator you type 8 minus 6.32 divided by 6, what's your calculator going to do first? 6 divided, or the 6 divided it. Yeah, it's going to do this first. So if you're going to do it on your calculator, you have to trap that in parentheses to do it correctly. Okay. So I notice a lot of you do have your calculators. I notice a lot of you don't. Make sure you, from here on out, bring them. Because if you come to the test and you're like, hey, I don't have my calculator, and be like, hey, I'm sorry. You're supposed to have a calculator for this class. Pardon? No, we don't do Scantrons here. Everything's going to be handwritten.
Would you recommend for this class scientific?
For this class, you have to have scientific, so that will do. Graphing is optional.
Makes it more handy.
I may have a question.
Okay, so we have the X Intercepts? Both of them? All right, let's keep those in mind. What's next step? E. Y-intercept. Has anybody noticed anything about the Y-intercept on these expanded form ones? It's always C, isn't it? No, I forgot the problem. Don't tell me. See, I can remember this. 2x squared? No? Okay.
That's 3x
3x squared.
minus 8x plus 2.
Oh, yeah, I was way off. Okay.
Hey, you tried.
Yep. Yep. There it goes.
Hey, 80% of the battles are showing up.
So 2, that number on the outside is our Y-intercept. So now we're ready to draw a picture. Our vertex is at 1.3, negative 3.33, right? So let's say this is 1, say this is 2, say this is negative 1, this is negative 2, and this is negative 3, let's just say. Then our vertex, I'm going to graph our parabola in red, is at 1.33, which is about right here, right? About 1 1/3. Then down 3 1/3.
A little bit further.
A little bit further than that. Move that up a little bit. I think, is that okay with you? Now, to make sure that you understand where it is, when I say you, the person who's looking at my graph, I'm going to go ahead and tell that person what that point is, to be clear. And then I have some other points. I've got my X Intercepts, which were at 0.28. So here's 0.28. I don't know, that's somewhere around here. If you draw it real big, then you can, it's easy to say there's some gray area in there, right? This is 0.28, and the other one's at 2.38. I don't remember. What was it? 2.38? Okay, so 2.38. It's almost 2.5. I don't know, somewhere in here. Again, we're not putting a man on the moon right here. We're just graphing a parabola, right? This isn't the Hubble telescope. And one more point. What's the other point I have?
The other Y.
On the Y, I have 2 up. 2, right there. And now, I'm going to draw a U, right? I'm going to also keep in mind that I have right through here an axis of symmetry, which is just going to keep me honest here in my drawing. All right, I'm just going to remember to try and draw it symmetrically reflected. And so I'm going to just kind of curl this up. Just kind of bring it through like this, okay?
The tests, is there going to be already graphs drawn up?
No, I don't give you anything. You have to draw the whole thing from scratch.
Should we bring graph paper?
You can if you want.
Okay, cool.
If you would rather do your own graph on graph paper, go ahead, but I just give you a blank piece of paper.
With a problem, like, fix it, do it.
What's that? I just give you, say graph this, yes. So
Go for it. Jump off a bridge.
here we go, this way, like this. Oh, I kind of missed it. You do your best. Here's the thing that you want to avoid, right? If you're doing a problem like this, right? Say you're doing a problem like this, and you come up with this information. You've got a vertex down here. I'll put V for vertex. And then you wind up with an X-intercept here and an X-intercept here. What's your conclusion?
That would be wrong.
Something's wrong, right?
Because it's a mirror image.
It should be a reflection. You should not have something like this, right? So either your X-intercepts are in the wrong place or your vertex is in the wrong place, which means you need to go back and double check everything. It should all look at the end like a parabola. Again, I've had students get this sort of thing and be like, okay, like this, and then like this.
You get them like half points.
I gave bonus points for that.
Well, in that case, we're all going to do that now.
All right. Let's see what else we've got here. Let's see if we can do this one. Look at 4.3.9. A quadratic function has a maximum at the point -2, 6, and also passes through the point -4, -2. We're supposed to determine the function. Figure out what the function is. Okay, so they're giving you the vertex. Which one is the vertex? So they're giving us the vertex is -2, 6. So let's start with the standard form. We know that any parabola should be able to be written like this. Do you all agree? We just need to figure out what A, H, and K are, right? If I know A, H, and K, I'm looking at a specific parabola. In this problem, since they told us this is the maximum point, that must be the vertex, right? So this is H and that's K. So then come back over here and tell me so far what you know. X what? plus 2 squared plus 6. So the only thing left for you to resolve is what? What is A, right? This is the only thing left. What's A? But they give you another piece of information. They give you that point -4, 2 lives on the line, right? I mean, lives on the parabola. -4, -2 is a point
We also know A
on
is gonna be
the parabola. Yeah, you know A is going to be negative because it says it's the maximum point. This is a point on the parabola, right? Which means when you talk about points in terms of functions, the input is here and the output's here, right? The input is x, the output is f of x, isn't it? So what I can say from this point alone is that when I replace x with -4, -2 should pop out. Yes? So I'm going to come back to this, which I was kind of still didn't know what A was. And I'm going to write A, I'm going to replace x with -4. And I know when I do that, what comes out should be what? -2. Now look at this equation right here. There's one variable here, right? A? So solve for it. Solve for A. What's -4 plus 2? -2, square it. 4. So this becomes -2 equals 4A plus 6. Subtract 6 on both sides, so -8 equals 4A. Finally, A is -2. So remember, all we needed to know was what A was, right? And we just figured out what A was. A is equal to -2. It's a coincidence. Yep. Yeah. Yeah, no, it's a coincidence. So this is -2, and that would be our final answer, because they want the function. So if somebody tells you what the vertex of a parabola is and gives you one point on the parabola, you should be able to come up with a function, right? How many points do you need to define a line?
At least 2 or 3.
At least 2, right? The minimum you would need is 2. If I give you 2 distinct points, you can define a line. If I give you 2 points, can you define a parabola? Uniquely. You need 3? You think you need 3? What do you think? I just gave you 2, though, and you gave me the parabola. Hold on, no. No. I gave you a special one, though, right? I gave you the vertex and a point. If I hadn't given you the vertex, you couldn't do this, right? So your instinct is correct. If I give you just 2 arbitrary points, there's not one parabola that goes through those, right? Here's 2 points. I can draw a parabola that goes like that through them. I can draw a parabola that goes like that. There's probably even a parabola that does something like this. There's infinitely many parabolas that can go through 2 points. But if I tell you that this one is the vertex, there's only one. Understand? Now, if I give you 3 points, and I don't tell you that any of these is a vertex, just 3 points, there is only one parabola that goes through them. But that's harder to do. We can do it, just not, we won't look at that yet. It's something we can address later. All right? So 2 points define a line, 3 points define a parabola. A vertex in 1 point also defines a parabola. All right, the last part of this is objects falling on Earth. And I'd like maybe to reserve that for after the test, because I think now with 20 minutes left would be a good time for us to just look at last semester's exam and kind of get an idea of what's going on. All right? So let me see if I can find it first.
Is it possible for you to post it as well?
Well, I'll post something. I don't know if I'll post.
That way we can kind of like practice.
Oh, I know what you want.
This we can have 2 tests to study for.
Here's last fall's. So let's make a list of the things that we need Okay, let's make a quick list of the things. When I say we, I'm not going to write anything down. You can. Go through this and think about formulas that you might need. All right, graph the function. The graph of a function f is shown below. Use it to answer the following. I think I've shown you this before, right?
Just write it down later.
Domain, range, where is it increasing, decreasing, where is it constant? Find the local maximums, local minimums, absolute maximums, minimums, x intercepts, y intercepts, where is it positive, where is it negative, and there's the function.
Yeah, you should.
Yeah, I think we did talk about this. That was the first problem. Next one, solving a radical equation. Do you need any special formulas for that? No? I'll send this out to y'all, okay?
Yeah, but I'm not, remember I'm not on the roster, so.
You're still not on the roster?
I've tried, I haven't gotten to the thing yet. I was gonna-
You better take care of that, because if you wait too long, they may not be able to. Well, they told you to come here, right?
Yeah,
Okay.
after I transferred over.
Okay, take care of that though. All right.
So you're gonna send this to us?
Solve a radical. I'll send this out. Yeah. Now, this does not mean your test is this test, with numbers changed. Just gives you an idea of what I've asked in the past. That's all. You always need to study all your homework and all the examples I do in class. That's what you should study. This is what I picked out of that last semester. I can pick something the same, similar, kind of the same, different, But I told y'all last time, I don't want y'all to get into this mindset that, give me a review, just give me a review, because that can catch up to you eventually. All right, this one is solving this is a quadratic type equation where you have to do that little substitution. Yeah, U substitution. Find and simplify the difference quotient. So I asked them to do a difference quotient on this, but it doesn't look like I gave them the formula for it. So just someone who's keeping track, this is definitely where you would need that's a formula you would need, right? Difference quotient? All right. Another difference quotient. We didn't really talk about this. See, this is a perfect example of something that I probably wouldn't ask you because I didn't really stress it, even though it was your homework. I don't know. Subtraction of two functions, division of two functions. Okay, find the domain of a function. That's definitely on the table. For this one, you have to solve a quadratic inequality. Ooh. No, we wouldn't do that. That's what we're supposed to do today. I mean, we're supposed to finish with that. I did not having time for that. So I wouldn't ask you that. Yeah. Average rate of change. That is definitely there. Slope of the secant line. That again, we did that in class. Sketch a piecewise function. Well, I did provide them the graph for that one. Graph a quadratic function. Include information up, down. Everything we just did, basically. That's an expanded form, right? I did provide them a graph. I won't provide you one, though, I don't think. The problem with if I provide you a graph,
Then we know where.
you kind of know where everything's supposed to go, yeah. And plus, I want you to draw your own. Okay, same thing. Now, we haven't done one of those. That's just in standard form, right?
Yep.
If you were asked to graph that right now, first, is it a quadratic function?
Yes.
Yes.
Okay, open up or down? Down. Do you know the vertex?
Yes.
212?
Negative 212, right? So that,
Just do that today?
huh?
Yeah.
Same
Question, I think. It's something similar at least.
Yeah.
Yeah, but we didn't graph the whole thing. Like, we did identify things, but look, we've got opens down, vertex is at negative 212. Quick sketch would be the next step, right?
Yeah.
Negative 2, positive 12 will put you up here. It opens which way? Down. Does it have X intercepts?
Yes.
Yes. How many? 2. How do you find them?
Take it back to expanded form and then solve.
Okay, that's why I wanted to talk about this. How would you solve this? How would you solve it? You would take it to expanded form first and then do quadratic formula or something like that?
Unless there's another way.
There is another way, but that way is correct. I mean, you could do it that way.
I would get my vertex, find my intercepts, and then just go from there.
What intercepts?
Like if there is an X or if there's a Y intercept.
Well, that's what I'm doing right now. This is X intercepts, isn't it? Isn't
Yeah,
this
yeah.
what that means?
Yeah, but at the very least, you're going to determine the y-intercept.
You could do y-intercept, yeah. So look, I want to show you how to find the x-intercepts on something like this. Can I subtract 12 on both sides? Yes? So subtract 12 on both sides. Wouldn't it become this? Can I divide both sides by negative 3?
Yes.
Yeah.
Yes. And it would become gone here and what over here? 4. Now what?
Do the root of each side.
Root each side, square root of each side.
Plus or minus.
And when you do the root, you have to do plus or minus. So if I root this side and root this side plus or minus, then this side's going to become x plus 2. This side over here is going to become plus or minus 2. Then you subtract 2 on both sides. And there are your two answers. So what's positive 2 take away 2? 0 is one x-intercept. And then what's negative 2 take away 2? Negative 4. So you have two different x-intercepts. Now you could expand it out. It's going to take you longer though that way. Okay.
So does that work for every standard formula?
Yes, if it has x-intercepts. If it didn't have x-intercepts, this wouldn't work.
Right.
But if it does, yes.
That's why I
Yep.
tell us to sketch first. And then
Yeah. You don't want to be going after something that doesn't exist. The unicorn. What else? Oh, y-intercepts. Remember how easy it was to find the y-intercept on the standard form? It's just that number on the outside.
F of 0.
Here, it's not as easy because you're supposed to plug 0 in. When you plug 0 in, it doesn't kill everything off, does it?
No.
You actually get 0 plus 2 is 2, squared is 4, right?
Negative 12.
4, and then times, so next, is that right? Something in right there. Yes,
You get to 0.
you get 0, don't you?
Yeah, that's what.
That's 0. So this is your x-intercept. This is your y-intercept is 0, right? And now you go draw it. So if you drew this, it would be vertex was negative 2,
2.
up 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're way up here, negative 2, 12. There we are. X-intercepts were at
Negative 4 and 0.
-4 and 0. So here's 0,
Yeah, that is the one.
-4, right? Like that. And your y-intercept is also 0, so it makes sense, right? Does that make sense that the y-intercept and x-intercept are the same? And then draw it. You have your axis of symmetry goes down the center. Looks like this really narrow looking parabola. Do you all see? I need to curve that up there. Okay? See if there's anything else on this test. Oh yeah, I already know what's here. It's not going to be on your test because we didn't have time for it. It's the falling object. A ball is thrown upward. Okay, so that gives you kind of a glimpse into the types of things that I did ask. Difference quotient, solving equations, graphing. All right? Yeah, I don't have time to really do any of the falling object stuff, but
Are we going to stay after the test, or take it?
no, this first test, we're just going to do the test and then you're out of here. Yeah, I don't think, for this class, I don't think we'll have time after any tests. I haven't made the test yet, so what I'm going to do, I'll tell you what I'm going to do when I make the test. I'm going to